So we are going to look at graphing higher degree polynomials over two separate videos. In this first one, I'm going to give you the process. We're going to write down some steps and we're going to see how they are applied to a problem. And then in the second video, you can go through some more examples until you get a little bit more comfortable. Okay, so here are the steps. If you have a polynomial function with a degree greater than 2, the first thing you want to do is identify the degree of that function. And you really want to note, is it even or odd? All right, because that's going to tell you a lot of information. You also want to know the sign of the leading coefficient. Is the leading coefficient positive or negative? Okay. Once you have these two things, you can identify the end behavior of that polynomial. End behavior. All right. You can identify the end behavior of the polynomial. What are the ends doing? Are they both pointing up? Are they both pointing down? Is it going up from left to right, down from left to right? All right. Then you're going to find and plot the zeros, and you're going to note their multiplicities. And remember, multiplicities tell us how the function behaves at those zeros. So you're going to want to make a note of their multiplicities. You're going to find and plot the y-intercept by plugging in 0 for x. Like we find the y-intercept in any function, we always let x be 0. And then starting with the end behavior on one side, you're going to connect all your points with a curve. Nothing sharp, no corners, all curves. And then make sure you're using the multiplicities of each root. So it's a lot of words. Let's see how it works out. Here's my polynomial p of x. I have 1, 2, 3 x's that would get multiplied together, so it has a degree of 3. The leading coefficient I can tell by looking at the numbers in front of each of those x's. So in this case, this is a 1 and a 1 and a 1. So 1 times 1 is 1. So the leading coefficient is 1. And those are all positive, so this is a positive 1. Degree of 3 with a positive leading coefficient, I know that it's going to start low and then end high. All right, so it'll have from left to right, it'll go up because the leading coefficient is positive, and the ends will go in different directions because the degree is odd. Okay, so the way we write that is we say as x goes to negative infinity, or as x approaches negative infinity, on the left-hand side, my function will also approach negative infinity. As x approaches positive infinity, on the right-hand side, my function is also going to approach positive infinity. Down on the left, up on the right. Okay, the next thing that we're going to look at are the roots. What values of x make this function equal 0? And if you're looking at the parentheses, you're going to say, well, in the first parenthesis, the value of x that makes that 0 is a -1. The second parenthesis, the value of x that makes it 0 is +1. And in the third parenthesis, the value of x that makes that 0 is -2. So I have 3 roots. They are at -1, +1, and -2. Okay? The last piece of information I'm looking for is my y-intercept. And I find that by letting my x value be 0. When I'm in factored form, I need to make sure that I'm plugging 0 in for every x and not just looking at the last number. It's not how it works when you're in factored form. So I'm plugging in 0 in the first parenthesis, and I have a value of 1. I'm plugging 0 into the second parenthesis, and I have a value of a -1. And I'm plugging 0 into the third parenthesis, and I have a value of 2. So 1 times a -1 times 2 is a -2. That means I have a y-intercept at -2. Well, now I know the general shape of my polynomial based on the degree and the leading coefficient, and I know the end behavior. I know the roots and the multiplicities of each root, and the multiplicities of each root in this case are 1 because each factor is repeated only once, has an exponent of 1. So each one of these roots is just going to go straight through, and I know the y-intercept, which is -2. So now I'm going to take all that information that I know, and I am going to connect all the points. So I know that I'm going to start low because of my end behavior. So I'm going to start down here. I'm going to go straight through -2. I have to turn around quickly so that I can go straight through -1. I have to go through my y-intercept and then straight through that third root. I double check that my end behavior is low on the left side and high on the right side. I've hit all of my x-intercepts and I've hit my y-intercept. So I have graphed this polynomial correctly.